Okay, I think the slightly confusing thing here is that we're told that it maps onto the point R, where R is in the W plane. So normally you're told where the point is, where it starts on the Z plane, and you're asked to find the locus of where it ends up in the W plane. Here you're told it is mapped onto the real axis, and so where does it come from, which is why I think this question threw some of you. So given that, rather than rearranging to get Z in terms of W, we'll just start straight away with W equals U plus IV and Z equals X plus IY. And substituting those into our transformation, we get U plus IV equals X plus I, Y plus 1, all over 3 minus Y plus IX. Obviously we want to realise the denominator, which we'll do by multiplying by its conjugate, 3 minus Y minus IX. Multiplying out the top is a bit of a slog, but we have to do it. Multiplying out the bottom should be pretty easy using difference of two squares. Okay, giving us that. You'll notice the way I've multiplied that out is by, on the numerator, first of all thinking about what the real part of the numerator is, and then what the imaginary part of the numerator is. Now in fact I can save time, I can now, don't need to collect up all the real parts. All I need to do is note that because it lies on the real axis in the W plane, that means V is 0. Because V is 0, the imaginary part on the right hand side must be 0. Doing it that way, I've solved a few steps of algebra and made it look nice and simple. This is simply a circle. We'll complete the square. And this is the same circle as we found before, so it does lie on